Hello folks, today I am with a new topic in the chapter magnetic field, and you can see here I have expressed the topic as force between two current carrying conductors. So till now what we have done is we said that we realized that when a current carrying conductor is placed inside a uniform magnetic field, it experiences a force. The force is called as Lorenz force, and the direction of the force is given by or can be determined by using left hand rule of Fleming. So if this is the direction of the magnetic field and this is the direction of positive current, let us say conventional current, then the direction of the thumb gives that of force. But what we have not realized yet is, can't the magnetic field be created by another current carrying wire somewhere nearby? So can't the magnetic field be created by another current carrying conductor somewhere nearby? Yes, it can. So what happens is, if I have a current carrying conductor, it will give some magnetic field given by this. So current here, magnetic field here, and if I place another conductor here, then what happens is, it is under the influence of magnetic field and it carries current. So it must experience a force. So that's what we are going to do today, and we will express the force with various orientations of the wire. So let's say we have two wires. So one is this which carries current I1 in that direction going away from the camera or you. We have got another wire here which is again going from your direction to the board. So it is away from you. Now if I have to draw its field lines, so it's a field line. So first of all, let us see its effect on this. So let us see whether there is some sort of force on this due to this. That requires that I draw the field lines here. So this is one of the field lines. So it will be somewhat like this, round. So like this, and like this. This will be another one. So in whatever way I draw, it is not a final until I draw this direction of arrows. Now one of them will go like this and strike here like this. So it will be coming like this, and then it goes like this. So that means on this wire, the magnetic field due to this is, let us say it is B12, and it is happening downward. So on this wire, the direction of the magnetic field is downward. Now let's apply the Fleming's left hand rule to find the direction of force. So here magnetic field is down like this, current is going in that direction, so current is going in that direction like this, and the force will be like this. So my shaking thumb is showing the direction of the force. So the force is towards the left. This is F12. So it is the force on wire 2 because of 1. Now let us see whether there is force on this because of this. So at this time, the second one is the main actor. So this is the second conductor which has got I2, and this is the first conductor which has got I1. So its field lines will be again round like this. So one of the field lines will be like this, one of them. Another will be like this. Whatever direction I draw, the direction is not complete till I draw these arrows. So like this, and the one which comes here will be coming all the way like this. So it will be coming from this direction, and like this, and it goes in that way. So this is the direction of the force here. So of the field here. So the field here is acting in upward direction. So we have the field here upward. We have the current here. Current is going away from you. So magnetic field, current going away from you, and the force here. So that's why this is the direction of the force due to wire 2 on 1. So due to wire 2 on 1. So that means if I draw it in combined form here, if I draw both of these things in combined form, so this is I1, wire 1, this is wire 2 with current I2. So this experiences a force in this direction. So this is F21, and this experiences a force in this direction. So that is F12. So that means they come near each other, and that's attraction. So that's why what we can conclude here is, if we have two wires which carry current in same direction, they will experience an attractive mechanical force. So they perform attraction, or they will be attracted to each other. So let's do the same for reverse directions. That means this is okay, and here current is coming towards you. So if that happens, let us see what else will happen. So I will draw it here. So this will be dot. So dot means that current is coming towards you. So all others are okay here. Magnetic field coming down, because of this it is like this, but here the direction of current has reversed. So what happens to this is, now magnetic field is like this, current coming towards you, to the camera, like this, and force will be like this. So that's why the force will be, this is the force, it is F12. So previously force was here, and now force here. Then after that, let's do the same for this as well. So here this I2 has got current coming towards you. So let me rub all these things. So rubbing would be a better thing. So it will cause reversal in the field lines. So in the field lines. So that's why all of these things should be reversed. These things should be reversed. So I will do that, of course. So here like this. So like this. Here it should be like this. Here like this. Here like this. Then it should be like this, like this, like this. So anti-clockwise, anti-clockwise, and here also it comes from somewhere else, and like this, and like this. So this is the direction of the field lines here. So now let's go for the applying left-hand rule of Fleming. So the field lines are coming down. The current is going in that direction, so should be somewhat like this, and the force will be like this. So this first wire will be experiencing force in this direction. This is F21. Now if I draw them combinedly, what happens is, so this is the first wire with current I1. It experiences force, let us put it separate here, force F21, and I have got this thing here, this is I2, and I2 experiences force in this direction when I draw it in a combined manner. So this will exert force this on this, this will exert force this on this, so that's why they are repelling each other. So this force is a repulsive force. So that means when current are in reverse direction, they will exert repulsive force on each other, like this. So now what remains here is two other cases are remaining. So one case is dot circle here, current coming here, this intact, current coming here, this intact, and the another is reverse of this. So current going here, coming here, current coming here, current going here. So let's go for one more. I'll leave the fourth one to you. So here also let me say that current is coming towards me. It is dot circle. So it is, so let me rub all these things. So I2 shouldn't be rubbed, I rubbed it, so it's a mistake here. So this is I1, this is I2. Now since I have, I'm seeing its effect on this, first let me see for its magnetic field. So it will be like this. So it should be like this, anti-clockwise. So what I must do is, I must reverse all these arrows. I must reverse all these arrows. So they will be. So reversal of arrows. Like this. Yes. And here, this also will reverse. So the magnetic field will be like this, going like this. So here it will be somewhere coming like this, and like this, like this. So what will be the direction of the force? So apply Fleming's left-hand rule. So in that case, what we have is the magnetic field here is going upward. Then the current here is coming towards you, and force will be here. So this I2 will be experiencing force here. This is F12. So this thing will be experiencing experiencing, this is I2, force will be here F1, 2. Now let us go for this thing. Let's change it, dot circle. So here what happens is, yeah, so now its field lines are like this, it's okay, it comes like this, so it's also okay. Now what happens here? So it will be the magnetic field coming downward, like field line coming downward, and current coming towards you, so force will be in this direction. So that's why force will be here. So this is F21. So the force here will be F21. So this is F21. So that means each wire is creating this sort of force. So they are suffering from attraction. So again, it's the same thing. If current is in the same direction, they will be having attraction with each other. So the first case and this third case. Now I am not doing the fourth case because I leave that to you, because that is you should also practice some on your own. Now what happens is, this is how we see the wires. So the wires carrying current like this or like this, I am observing like this. So what if I observe like this? If I observe like this, if I observe current going like this, so how do I know the force? How do I know the direction of field lines as well as the force? So let's go for that also. So here, this is the first conductor in which let me say the current is going upward here. This is I1. This is the second conductor in which current is going upward. Again it is I2 and I2. So let's go for the direction of the field lines. So we have this and this. So here the field lines will be going like this and like this. So these are the field lines. So they will be going into the direction of the board at this side. But if it is this side, it will be coming like this. So but here we are not concerned because there is no conductor here, so we are concerned with this only. So this is the direction of magnetic field line. So it is a B12. Now with that magnetic field and that current, let's see where the force would be. So magnetic field here, going there, current upward, force here. So the force will be in this direction. This is F12. Now let's go for the field lines here because of this. So this thing will be exerting. So this thing will be exerting a magnetic field like this here. It exerts magnetic field like this here. So here we are not concerned because no conductor here. The only thing is we are concerned at this side. So magnetic field will be coming somewhat like this. So that's why it will be dot circle. So it is B21. Now with this magnetic field and this current, let us see where force is. So magnetic field is like this, force current is upward like this, and force here. See, and see the direction of the force. So if I go the reverse way, I can do it the same way also. This is the direction of the magnetic field, current upward, and force here. So in both cases force will be to the right. So the force will be right, F21. As I have said, whether I am at this side or that side, if I face the magnetic field and current properly, the force will always be same. Because it doesn't change according to my position. It is there. Only that the way I am showing is different. So in this case I have done like this, according to the comfort of my body. So here I am showing like this, and in both cases you can notice the thumb is towards the right. So that means F1 to F21 means they attract. So again the same thing. So if I reverse it, let us see. So let me rub this. So now let me reverse current in one of them. So let's say I reverse the current in the second one. So its field lines will be again the same thing like this. So this is cross everywhere. cross everywhere. So B12, and here the force will be, now let us go for the force. Magnetic field that direction, and current down, force should be to the right. So this is F12. Same thing at this side. The magnetic field, because of this thing on this will be, it is going like this, so like this, so it will be cross here again, cross everywhere. So if you ask can it be cross in both, yes, of course, why not, because we showed it. So current is going like this and it should be like cross. So magnetic field is going away from you. Now if you have to find the direction of the force, it will be so magnetic field going here, current going up, and the force will be to the left. So this is F21. Now see, both the wires are experiencing forces in these reverse directions. So that means that they repel each other. So when the directions are reversed, they repel. So there's lots of there are two other cases as well, in which both will have current going in downward direction, and here this will be reversed. So however we see that, what happens here is, when current is in same direction, the magnetic field will be such that they will attract each other. They create forces such that they attract each other. When current is reversed, they will repel each other, and they have got great practical implications in a normal life, as well as in highly technical terms as well.